Okay, this is what you see. This is an aircraft. The aircraft is loaded with many things. We have drag, we have thrust, we have pressurized, we have all the load due to the weight of the aircraft, due to the engine, due to the, it's loaded everywhere. So what we have in the aircraft are loads, which equal to forces. And we design the structure to carry all these loads. That's why some university they call it strength of the materials. Because what we do, we want to look at whether the materials that we choose to make the structure are strong. How you do it? You have to determine the stresses on each structure member and compare with the material strength. I think I have given you the example earlier. Example, the one that we go through earlier with the simple rod and beam example. That is a good example of the process. How to get how to understand, how to determine the stress of each member, and how to compare with the material strength. Each material having the strength. Okay, now we need to look for the stress. We have said that we are looking, okay, the stress. Determine the stress. What will be the potential stress? So what we have tension. So this is tension failure. The stress will cause the material to fail. This one is axial failure, axial stress, which give you the axial failure. Axial either tensions or compression. What you saw is tension. So the part will break up after you apply the force. You apply the force in this direction. Okay, in this direction. Okay, this is a force. And then you divide by the cross-sectional area. You got the stress, force over area, and you compare with the material. If it is higher, then you have this failure. What else we have? We have also bending. Okay, we have torsion. This is torsional failure. You twist the structure member, it will fail due to the torsion. What else you have? You may have bending failure. If you bend, you have structures. This is the wing, for example. The wing, you apply load, the wing will bend up, and then it will fail. So this is bending. And then this is a formula for bending. We go to that later. And we also have shear failure. Shear failure. Shear failure, where we apply the load. For example, this is a load here, say 10 ton. Opposite load of 10 ton. So this is shear. So we have to know how to calculate them all. So I just throw in the simple formula first. So also you also may, okay, this is tension failure, this is shear out failure, this is bearing failure, this is also shear failure. So this is on the rivets, on the fasteners. You also can have failure on big component structure. For example, you also can have small failure on the bolt and nuts. And this is the torsion stress. I throw in the equation first before you before we go to the theory. So for the bending failure, okay, bending stress, tension stress, I think we already know. Okay, tension, which is force over area. Okay. For the bending, you got the bending, we bend something. So the top here is under compression, shear, compression. Here is stress, tension. So how to get that stress? Your equation will be stress, moment, time y, which is neutral axis, divide by modulus of divide by moment of inertia, sorry, which you have learned already in your static. So here is a moment. The moment is from the force over the distance. Okay, force over distance, say x here. So here is force time x, moment, time the moment, radius, natural axis. Natural axis is the axis where no change occurred. So here is natural axis, y, and moment of inertia depending on the cross-sectional area of the part and component. So this is how to moment of inertia. Then you got the shear stress. The shear stress, if you go to the top, is in compression, and go to bottom is in tension, and it's reverse for the aircraft when the aircraft is on the ground. So that's one. Moment of inertia. Okay, for the tension, for the bending, you have two conditions. Okay, we have here is tension. You can see here compression. The top surface compression. The bottom surface will be in the tension. However, the equation is the same. Moment, time, the natural axis over the moment of inertia. You will get the stress for both top and bottom. For the if you bend up, the tension will be at the bottom and compression at the top. Use the same equation. So this is something you need to understand. But we can derive the equation. Okay, so up to here. But I don't think you are interested. If you're interested, we can go through, no problem. I will go through anyway. However, for you, if you having to solve bending issue, you just take this equation. So this is bending stress. This is axial stress, tension, compression. This is a stress, also tension and compression. However, due to the bending.
Sir,
Yeah,
moment of inertia tu nak dapat kat mana sir?
you have to calculate depending on the shape and size. For the simple shape is 1 over 12 B H cube, if I'm not mistaken. So this is B, this is H. So different shape, there's a different formula. Moment of inertia is the resistance for the uh, for the for the part to be bent, resistance of bending.
Okay sir, thank you.
Okay. Okay. Now this is due to the bending. If we got torsion, the torsion here is shear. Okay. Remember, there's no such direct. Here, bending give you axial stress. So it's still go back to the fundamental axial. Bending, you bending thing up and down, you resolve into a shear stress, either compression or tension. Back to this fundamental. Okay. For the torsion, it's back to the fundamental shear. Because if you twist part, the part will fail in this manner. And this kind of failure is a shear failure. Either you got 90 degrees or either you got it an angle. However, this is still shear failure. Means that torsion give you shear failure. And then we talk about bending. Give you axial stress failure. For the torsion, shear stress failure. You can see the formula shear. Shear here is top. Top, T, top, time C, this the radius. C is the radius of the rod and J is the modulus. Okay, J is also you can calculate. It is almost similar to the moment of inertia. So what we can summarize here is we have basics. Failure mode of failure. We have axial, which is tension or compression. Okay, if we have mode of failure of shear, okay, will give you shear shear is shear. Shear is, yes, it's another shear. The difference between shear is the area. Okay, shear is tau equal to force, similar again, divided by area, but this area is parallel to the force. So we have beam here. We try to cut the beam. This is shear failure. So the area is the area, cross-sectional area, parallel to the force. That is the difference compared to the tension. Okay, this is tension, this is the force, time the area. Divide by area, sorry, the area here is the area 90 degree to the force. For the shear is 0 degree to the force. So it's different. So axial tension compression, this is a formula. Shear, this is a formula. Still force of area, only the area is in different mode. Okay, now we have another one. We have torsion. Torsion also give you shear. We have another one. We have bending. Bending up, bending down. You got also axial stress. Either tension or compression. So we only, whatever we do, we depend on this same equation. Okay, force over area. Okay, enough for the review. And from now on, I will go to the detail. We go into the theory, bending, crippling, buckling, torsion. Those are the details. So we have 2 more weeks to the midterm because we have class for 2 more weeks, and then you have a break for a week, and then we start the class again. Then we start the first week we do the midterm. And the midterm will be covering to what we have learned so far up to this point. I really like to concentrate on all the stresses, how to calculate the stresses. I may not give you all the detail. I won't expect you to derive all this equation. The equation is derived to understand how we get the equation, but most importantly for you to know the equation to use for what problem, and how to get the parameters from the problem for you to fill up in the equation for you to get the answers. Okay, so far you okay?
Okay, sir.
Okay, sure. Anyone find it tough? Anyone you find I'm also tough to deliver to you? Please be honest, because I have to improve my way of delivering to you. If you feel this is tough, because why? Because to me it's not a problem. For the people who do not understand there is a problem, then I have problem. You will have problem. You know what I mean? To me, it's something that I do, so it's not a problem. I don't see it as a problem. But I may be explaining to you, expecting you already know a lot of things. That is my worry. If I expected you to, if my expectation is that way, mean I did not give you the detailed steps how to understand it. Then I be jumping here and there, and you end up with not able to understand fully on the subject. Okay, you know what I mean? I do not know how much you understand your mechanics of your mechanics of solid, because this is the basis. The basis you should go to mechanics of solid. You should understand them well. For example, you asking about moment of inertia. I don't mind you asking all the basic fundamental, but those are already covered in the mechanics of material, mechanics of solid mechanics. I don't know whatever you call it, which is static and dynamic for most universities. Okay, guys. Questions? Any questions?
So far, no, sir.
No? Okay. Then we can stop here. Okay, see you next week. And if I got time, I will let you know. I will put in the quiz for you.
Okay, sir.
Alright, thank you. Assalamualaikum.
Thank you, sir.
Salam.
Salam.
Thank you, sir.